In this video, we're going to be covering another Amazon's interview question. This is question number 22, generate parentheses. And today is December 6, 2022. This is the first time I'm seeing Leetcode's new UI. They have changed a lot of things. They have added a debugger only for the subscribers. The look and feel has been changed. I think the test cases are, maybe it was similar before too, but you can add multiple test cases at the same time instead of tweaking the same test case, um, the value for in the same test case. And other than that, they have been changed to the discussions, solutions, and there are a lot of changes being made over here, and that's nice. So in this question, we have n equals to a number, and we're gonna be generating all combinations of well-formed parentheses. A well-formed parenthesis is gonna be where we have equal number of opening and closing parentheses, and the opening parenthesis at any point in time, if you look from left to right, opening parenthesis is gonna be more than the closing parenthesis. So you cannot have a closing parenthesis and um, any number of closing parentheses more uh, than the opening parenthesis at any point in time. So basically, we're going to be using the depth first search. Depth first search, to me, when it comes to the depth first search, what I mean by depth first search is there are a couple of things. One is there's going to be a recursion. We are not going to be using a queue or a stack, and it's going to be recursive calls. So we will not be using any stack or queue, because using stack and queue makes it breadth first search, and like in depth first search we are actually going uh, deep in the recursion, where the breadth first search is kind of, we have an element and we're looking the neighboring elements, um, and stuff like that. So here's a sanity check. We are, when the n is less than equal to 0, n is the number of well-formed parentheses we need. If it is less than or equal to 0, we're just gonna return the empty list of string. We don't would so this is what we're gonna be returning. And then we're gonna start our function with the empty list of strings, which is gonna what we wanna return, and the current string is gonna be empty, and then the n is how many opening parentheses we still have to use, and how many the count over here is how many closing parentheses we can use. So when we are sending it this thing over here, um, oops. So all it does, let's just go through this logic first. So all it does is when you send these things to this helper function DFS, it looks at this one. It looks at the n, how many parentheses, opening parentheses we still have to use, and how many closing parentheses we can use. If the both are equal, whatever is the value here, we're gonna make it part of the result. That's the first logic. If n is equal to 0 and the count is equal to 0, whatever the string you have, just make it part of the result and return. If at any point in time any one of them, the total number left for the opening parenthesis and the total uh, numbers we have for the closing parenthesis. If any one of them goes below 0, just return. That cannot be. What it means is like you were allowed to use 1, but you have used more than 1. You were allowed to use like the closing parenthesis x amount of time, and you have exceeded that amount, so you cannot put the current string into the DFS. So when we go in here in our helper function, we are actually doing every single time we're going to be doing two things. We're going to be adding an opening parenthesis and remove that number from here, that how many opening parentheses we were able to use. How many, like we had a total number of opening parentheses we had in the option, so we we're gonna decrement that. Also, whenever you use an opening parenthesis, this is gonna get incremented because now you have one more choice of using the closing parenthesis. And and also we're gonna be using the same function with the closing parenthesis. This time this doesn't get affected because we have, when we are making use of this one, the closing parenthesis, our opening parenthesis, number of opening parentheses we have used so far doesn't change, but the number of closing parentheses we can use is gonna get decremented. So when you are sending this, you are gonna be calling two functions. For two times you're gonna be calling the helper function again. The one is you're gonna be adding the opening parenthesis, and this is gonna get decremented, this is gonna get incremented. So this is 0 and this is 1. And the second in the next line we are also calling the DFS by appending uh, closing parenthesis to the current string. This is not gonna get affected, but this is gonna get decremented. This will no this won't work because our sanity check is, the base cases are that whenever it goes less than 0, any of them goes less than 0, just return. So this is not gonna get go any further. This one, which is the same line as this one, is again we're gonna see that both of them are not 0, so this cannot become part of the result. And we are gonna have, and both of them are not less than 0, so they do gonna call these two functions again. They're gonna call the helper function again. By one time they're gonna be adding another opening parenthesis, and this time this is gonna get decremented, this is gonna get incremented, just like over here. But later on this won't go any further because if any one of them becomes negative, we're just gonna return. Whereas this one, we are adding the closing parenthesis 0 because this is not gonna get changed when we are appending a closing parenthesis, but this one is going to become 0 because we are gonna get decremented. So both of them are 0 over here, so this and this, so this thing is gonna be DFS 6, can also be written as here 0 and 0. This is the condition over here. When both of them are 0, we're gonna take our current string and make it part of the result and return. And we're gonna be returning this one, so this is gonna be the only answer. If n is equal to 1, this is the only valid combination combination of well-formed parentheses. In terms of the time complexity, space complexity, So if we have so if we have n number of integers, right? We are going into the depth first search, and every single time one can call one can trigger two more DFSs, right? Although we have the sanity checks, we have the base cases here, which can whenever they go. So we won't let them the invalid to wander around too much. So uh, we are whenever they become negative, we just do not do that. So it's not like 2 raised power. Uh, so it's not like 2 raised power n because of that. But like one number can actually trigger two other ones every single time, right? And but it is gonna be so one is gonna have this answer. So basically it boils down to if you look into like what is gonna be the so for one array the answer is gonna have one string. For two it's gonna have one like this, this, and that would be it. For three, so for two it's gonna be like that. For three it is going to be 4 5, so that's 5. So in terms of space and time complexity, actually the complexity is 4 raised power n divided by square root of n, and the analysis is out of scope here. One thing I do want to point out is like the reason we do have a space complexity just like the time complexity, and they're the same, is because we are using a stack, and every single time we can actually go into uh, these uh, these recursive calls. So there's always um, a stack space we are taking because we are making the recursive calls, and our stack pointer needs to remember that. Yeah, just think of it as like even if you would not have been doing it recursively and using the breadth first search or recursive way, iterative way, you would have been using a stack or a queue. So that would take it would more or less take the same amount of space. That's all I wanted to cover in this video. Thanks for watching.